can find what is the Z, that is impedance. Okay, magnitude of impedance you can calculate. If you know that AC source voltage as well as frequency, along with the frequency, if you can note down, then you can find the L value easily, because you know that XL is nothing but root of Z square minus R square. Once you know XL, you already know frequency, L can be easily determined. So this is how you can determine the choke coil parameters. Now let us also look at the series and parallel combination of inductors. First let me look at series combination of inductors. Okay, so let me take L1 and L2. This is L1, L2. The flux linking here, it is a phi 1. Okay, and then phi 2, phi otherwise. Okay, the total voltage given here is voltage V. Voltage gets divided, yes or no, plus minus V1 plus minus V2, yes or no, all of you. So here the current is same. Getting all of you? The current is same. Now LAB can be taken as, what is LAB? What is LAB? LAB is nothing but L1 plus L2 and so on, Ln summation I is equal to 1 to N Li. The effective inductance will be always greater than, okay, the highest value of L1 and so on, Ln. If you take N is equal to 2, obviously LAB is nothing but L1 plus L2. Now, what's happening here? Series combination, what is that actually? Series combination, current is same, okay, current is same, but the voltage divides. Voltage divides nothing but what? Flux divides. Phi 1 and phi 2. The flux divides. Understand all of you, okay? Current is same, but flux divides. Now, since phi is directly proportional to I, or phi 1 is equal to L1 into I, phi 2 is equal to L2 into I, you know that, okay, phi is directly proportional to L. The flux gets divided in proportion to the L value, and total flux is nothing but phi 1 plus phi 2. Understand, okay? This is what the total flux. Now from this we can say the phi 1 is nothing but L1 by L1 plus L2 into phi. Phi 2 is nothing but L2 by L1 plus L2 into phi. This is what you can say flux division rule. Okay. Now coming to the parallel combination. Okay, the parallel combination. Series and parallel combination, in that we are taking first one series combination, second one we will take parallel combination. Parallel combination of inductors. Please proceed. You can write this. It's all easy things, okay? You can follow. This is L1 and L2. Okay, the flux is same. Okay, because the voltage is same, but current whatever you send, it gets divided. It gets divided. In this parallel combination is nothing but flux same for both the inductors, but current gets divided. If you send some current I, it gets divided. Okay. Now LAB, 1 by LAB, yes or no? 1 by L1 plus and so on, 1 by Ln. LAB is nothing but 1 by summation I is equal to 1 to N, 1 by Li. The effective inductance value gets decreased when inductors are connected in parallel. lowest value of less than lowest value, here greater than maximum value, exactly reverts to the capacitors or same as resistors. Okay, n is equal to 2. LAB is nothing but L1 L2 by L1 plus L2. Now coming to phi is equal to L1 I1. Same flux in the case of second inductor also. From this we understand I is inversely proportional to L, and I is equal to I1 plus I2. This we already know very well. Current divides in reverse proportional or inversely proportional to the L, yes or no? So now here I1 will be L2 by L1 plus L2 into I total current. I2 nothing but L1 by L1 plus L2 into I. This is nothing but current division rule, you can say. Flux division rule, current division rule. Okay, there again we have seen voltage division rule and charge division rule. Like that you can proceed. Okay, so please quickly complete all this. We will switch on to again start delta transformation formulas quickly. Do it all of you quickly. Delta to star. I'm just writing the formula here. Note down all of you. Please note down. Denominator is same in this case. Please complete that quickly. Start with the delta to star. Okay. Delta to star. Now star to delta. Please complete that. I'm just writing formula. Divided by LC. LBC, the numerator is same. LA. LCA, the numerator is same. LB. So these are all the formulas for star to delta or delta to star. Okay, note, if LAB is equal to LBC is equal to LCA is equal to L delta, LA is equal to LB is equal to LC is equal to L star. Okay, if you take like this, then from this particular formula, that one you can see delta to star. I think L star can be written as, okay, L delta by 3. Okay, so 1/3 of the delta element will be the element of star if they are equal. Okay, or else L delta is nothing but 3 times the element value of the star. Okay, this is how you can derive the formulas. Very important but simple. Already you know inductors, resistors and conductance formulas. Resistor formulas, inductor formulas look similar. Capacitor formulas, conductance formulas look similar. Okay, right. Quickly complete them. We can switch over to some problems on inductors and capacitors. Okay. Classroom workbook, problem number 1. Read that question, all of you. Determine the voltage across 2 microfarad if current through it is I of t is equal to, it is given as 6 into e power minus 3000 t milliamperes. And what is the capacitance value given? 2 microfarad. What is he expecting? He is asking voltage across the capacitor. That's it. It's a direct question. What is the relation between current and voltage in case of capacitor? Yes, all of you? A simple one. I'm just directly solving it. You know that V of T naught, okay, or else 0. If you take 0, then plus 1 by C integral 0 to T, yes or no, I of T dt. This is what initial voltage. Sometimes he will give you the information directly or indirectly. In this particular problem, he did not talk about the initial voltage. Therefore, when anything is not mentioned directly or indirectly, you can assume that initial voltage to be 0. Okay. Well, now 1 by C, that is nothing but 1 by 2 microfarad 10 power minus 6 integration 0 to T 6 into e power minus 3000 T dt. You know that already it is in milliamperes, therefore it is 10 power minus 3. It is in amperes now totally. Now 1 by 2 into 10 power minus 6. Please do calculation all of you along with me. 6 into 10 power minus 3. Now e power minus 3000 t by the integration of it, you know very well, minus 3000 0 to t. Please simplify it. Okay, you can easily simplify this particular one. I'll give you directly that answer. Okay, 1 minus e power minus 3000 t is the answer, volts. Note down all of you quickly. Very simple problem we started with. Classroom workbook, question number 2. Question number 1 is over. Question number 2. Determine the current through a 200 microfarad capacitor whose voltage is shown in the following figure. Okay, voltage is given. Now he's asking what is the current through the capacitor. Okay, but instead of the mathematical function of the voltage, he has given the waveform. The waveform is given. Can't you define mathematically that waveform? Yes, we can. Okay, so we'll do that. We can also draw the corresponding current waveform. This is what the waveform given. Let me draw it carefully. This is 1, 2, 3, and 4. This is T, V of T, 50, minus 50. Okay. What is the capacitance value given here? 200 microfarad. Yes or no? C value given. Now let us define mathematically. How you define mathematically this voltage waveform? See, the voltage waveform is given here. Okay, volts. This is in volts, and this is in second. Okay. Now this is the line passing through the origin. You can define V of T is equal to, what is that? 50 by 1. Yes or no? 50 by 1. You have 50 magnitude and 1 is the time. So therefore, the line passing through the origin Y is equal to mx. This 50 T for T between 0 to 1. Understand all of you? Okay. Now what about the other one? It is a line with a negative slope. What is this point actually here? 1 comma 50. What about this? 3 comma minus 50. Yes or no? So you can find the straight line with a negative slope. This is x1 y1. This is x2 y2. So y minus y1. What is that y minus y1? Y minus 50. That is v minus 50. I'm just doing that rough work here. V minus 50 is equal to m. M is nothing but what? Minus 50 by 3 minus 1 T minus 1. This is what you are getting. What is this? Minus 100 by 2 T minus 1. This is 50 again. So what do you get? V is equal to minus 50T. This is minus into minus plus. Is that all of you? Minus into minus plus 50. Again plus 50. You are getting plus 100. Understand all of you? Okay. So you get minus 50T plus 100 for T between 1, 2, that is 3. Again you have, this is a negative slope, this is a positive slope. What is this again here? 4 comma 0. Yes or no? So what do you get here? Again you can do some work here. Okay, let me do here. x1 y1 x2 y2. What is that? Okay, v minus of minus plus 50 is equal to m value 0 minus of minus 0 plus 50 by 4 minus 3. Okay, T minus 3. Yes or no? Okay, so what do you get here? There is already 1, so 50 into 3, 150 minus 150. This is also minus 50, so minus 200 V of T. So plus 50T minus 200 for T between 3 to 4. This is what actually the systematic way of work, but definitely in exam it will take a lot of time to understand. Okay, you can directly go for, okay, see, after finding this, what are you supposed to do? Tell me. Current is nothing but I is equal to C dV by dt. Yes or no? But you already know that this is nothing but what? Slope. This is nothing but slope. So slope calculation, if you see directly when you differentiate, what are you getting? Plus 50 for T between 0 to 1. Next, minus 50 for T between 1 to 3. Again plus 50 for T between, okay, 3 to 4. But actually here C value is there. What is the value of C here? 200 into, okay, the 200 microfarad into 50. This is 200 microfarad, 10 power minus 6. It is also, how much it is going to be, tell me all of you. This value, if you calculate, it becomes 5 into 2, 10, but 10 kilo into micro, finally 10 milliampere you get. So here also you get now, this will also be minus 10 milliampere. Now this will also become what? Plus 10 milliampere. Understand all of you, okay? So there is no need to find the equations and all. Directly you can go for the slope calculation. Okay, this entire work need not be done. I'm just explaining you how you can mathematically that you can form. Understand all of you, okay? If you're really expertise in all this, okay, there is no need to calculate all these things first of all, but just want to show you somewhere this experience will help you a lot in defining the waveform mathematically. That experience will help you somewhere, okay? But since they're all straight lines, you can already have the slope, well-defined formula. Then this is plus 50 volts per second. Yes or no? This is minus 50 volts per second. This is plus 50 volts per second. Understand all of you, okay? Now what is that current directly you are getting? Current is nothing but this volts per second into capacitance only. That's what you got, 10 milliampere. So I can also draw that waveform directly here, okay? Sometimes he may ask you which one of the following is the current waveform for the given voltage waveform across the capacitor. So you need to draw that waveform also. How you get it, tell me. So I of t, if it is in milliamperes, let us say, if time is taken in seconds, let us say, now tell me what you get here, 10, yes or no, then minus 10, then again plus 10, that's it. You are going to get like this. So 10 and minus 10. This is 1, 2, 3, and 4. That's it. Okay. So this is the waveform you got. This is the waveform you got. That's it. Okay. Note on that quickly, all of you. Note on that. Understand all of you, okay? We just sketch the corresponding current waveform for the given voltage waveform. So whenever you come across the waveform and I is equal to c dv of dt, first derivative term, just go for the slope calculation. Don't derive all these things. It's a time waste process. Just I have shown how we do it. But in fact, these calculations are not that much required for the given problem. Okay. Obtain the energy stored in each capacitor shown in following figure under DC conditions. Under DC conditions, is asking what is the energy stored in each capacitor. Let me draw the circuit again here. All of you can also draw quickly in your notebook. Draw it once again. Okay, I'm just drawing the diagram here. Circuit diagram. 2 millifarad, 2 kilo ohm, 4 kilo ohm, 5 kilo ohm, 4 millifarad, 3 kilo ohm. Okay, this is 6 milliampere. This is C1 and this is C2. So he's asking what is the energy stored in each capacitor under DC conditions. Okay, so let's solve that. What do you mean by DC conditions? Under DC conditions, how the capacitor behaves. Under DC conditions, how the capacitor behaves. What is the behavior of the capacitor? It acts like open circuit, yes or no? It acts like open circuit. So therefore, Let us draw the equivalent circuit for DC conditions. DC conditions, steady state conditions, usually when a DC circuit is given, okay, when the DC excitation is given, under DC excitation, definitely under DC condition, DC excitation is given means DC conditions definitely, or in steady state condition, sometimes he will mention in the problem, okay, the capacitor behaves like what? Open circuit. So let me draw the circuit again here. How does it look like? This is an open circuit. Physically capacitor is there but is acting like what? Open circuit. This is C1. Let me highlight the capacitor. This is C1. This is C2. So if you know the voltage across each capacitor, you also know the energy of the capacitor because W is nothing but half CV square. So this is now 4 kilo, 5 kilo, 2 kilo, 3 kilo, 6 milliamperes. Now tell me, since it is open, this is also open, this 2 and 4 are connected in series, yes or no? This series combination is parallel to 3. If you can find current here, find the voltage. This voltage is nothing but voltage across C2. Agree or not? Because it is open, you can neglect this. These terminals are same as these terminals, nothing but voltage across 4 ohm. So let me find the current through 4. But current through 4, current through 2, current through 6, all are same. Even if you are asked to current through 4 or current through 2, you must calculate current through 6 because these two are connected in series. So therefore, I can find here, let us say, this current is getting divided, say this is I1, okay, say this is I1, okay, this is I2. Understand all of you, okay? So what is I2 here? I2 is nothing but opposite resistance 3 by 3 plus 2 plus 4, 6, that is into 6. Now 3 3 ja, 3 2 ja, that is 2 milliamperes, I got it. Now I get V1 is nothing but, okay, 2 into 2, that is current flowing here, 2 into 2, that is 4 volts, because milli and kilo gets cancelled. V2 is nothing but 4 into 2, that is 8 volts. Now what is W1, Nana? W1 is nothing but half. C1, what is C1 value? 2. What is V1 value? 4. 4 square. 2 into 2, 16. Already this is millifarad, therefore millijoule. W2, half. C2, 4. Voltage, V2, 8. 8 square. 2 2 ja. 64 into 2. 64 into 128 millijoule. Okay, I think you understand that problem. Quickly complete that problem. Quickly complete that problem. Quickly complete that problem. Meanwhile, I just note down another one here. All of you understand that under DC conditions, the capacitor is acting like open circuit. That's an important point to be observed. Okay. He's asking C equivalent, CAB otherwise. 60 microfarad, 120 microfarad, 20 microfarad, 70 microfarad, 50 microfarad. Is expecting or is asking what is C equivalent or CAB. Equivalent capacitance across AB terminals is another simple problem. Okay. So what is that? How do you find? Okay, simple series parallel combination. These two are connected in series. That result is parallel here with 20 microfarad. These two are parallel. That result and the result what we got just now a little while ago, both will be in series. Yes or no? So let me find that. 120 series 60, nothing but what? 120 into 60 by, I think all of you remembered capacitors in series formula C1 C2 by C1 plus C2. This is definitely 40 microfarad. And that 40 is parallel to 20. This will become 60 microfarad. So just keep it aside for a moment. And 50 parallel 70 will give you 120 microfarad. Okay, and now these two, 60 is in series with 120, nothing but 40 microfarad. So this is nothing but your C equivalent or CAB. Please complete that quickly. Okay. Fifth one, classroom workbook, question number 5. Find the voltage across each capacitor. Find the voltage across each capacitor. Find the voltage across each capacitor. 60 microfarad, 30 microfarad, 20 microfarad, 40 microfarad, 60 volts. We need to find voltage across each capacitor. That's the question given. Okay. Assume that the voltage across this one is V1. The voltage across this one is V2. The voltage across this one is V3. And this one is V4. Okay. Understand all of you? Okay. So let us go for the voltage division rule directly. Okay. Voltage across each capacitor is asking. And this entire combination is excited by what? 60 volts. Is it DC or AC? DC. So each capacitor is acting like what? Open circuit. But physically the capacitor is available. Their behavior is what? They're acting like open circuit. Now let's try to create two series capacitors so that I can divide the voltage. Now this is one series. The other series capacitor can be determined up to simplifying the entire part of this up to these two terminals. So let us do that. What is this? Plus minus 60 volts. This is 40 microfarad. 60 and 30, they are in series. Okay, when they are in series, 60 series 30 will become 20 microfarad. 20 and 20 parallel will become addition, right? 40. So this is a 40 microfarad. So when you look at the 60, it gets divided into two parts. Since these two are having the same values, equally divided, yes or no? How much it is going to be? 30 volts and 30 volts, because these two are same. Understand all of you? Now let us go back to the original circuit. So here it is what V1. Now V1 we got 30 volts. And the voltage between these 2 points and the voltage between these 2 points is same, that is nothing but V2. V2 is equal to also 30 volts. Now further this V2 can be divided among these two elements. If you go back to the original circuit, this is a circuit which you have drawn initially to divide the voltage. You actually created two series elements for your convenience. After that, go back to the original circuit. Now divide this voltage among the two elements. So what will happen here? V3 will become, these two are in series. When these two are in series, the total voltage divided, now V3 will become, now C4, that is 30 by 30 plus 60 into, what is this value? V2 how much? 30 volts. That's it. Now 30 into 30, 90, 30 plus 60, 90, 90 by, okay, Sorry, this is 900 by 90, that is 10 volts. Now what is the remaining voltage? There is no need to calculate. 30 minus 10, because to satisfy KVL in this loop, 30 minus 10 will be the next one, that is 20 volts. This is how you can calculate the voltage across each capacitor when DC excitation is given. Okay? Note it down, all of you. Quickly complete. Sixth problem, classroom workbook. Find the voltage across and energy stored in each capacitor in the following circuit under DC conditions. So the similar problem gets repeated here. All of you please draw the circuit again. All of you draw the circuit again. Just draw the circuit again. This is 6 farad. This is 2 farad. 10 ohm. 50 ohm. 20 ohm. 60 volts. 30 ohm. C1 and C2. Okay, so we need to find what is V1 and what is W1, what is V2 and what is W2. Okay, both energy as well as voltage. So of course, once you know the voltage, you can find the energy easily. Yes or no? So now DC conditions means what is acting like open circuit. It is also acting like open circuit. So all of you draw the network again, but I'll make the modification here itself. Okay, since under DC conditions he mentioned, let me draw its circuit as something like this. Okay, this one also. I'm just replacing it by the open circuit. This is capacitor. Physically, this is also capacitor. Physically available. Yes or no? Okay. Now let us look at it. Since it is open, now this is also isolated completely. You cannot expect any current in this element. Since this is open, all these three are becoming in series. Yes or no, all of you? Now this is what actually the voltage that can be divided because all elements are connected in series. The voltage across 30 ohm is nothing but voltage across this capacitor. Yes or no? Okay. Therefore, look at this. Look at this, all of you. The V1 can be calculated 30 by 30 plus. What is that? 30 plus 10 plus 20 into 60. So 30 plus 20, 50, 50 plus 10, 60. Therefore, total will get cancelled and you got 30 volts. Understand all of you? Okay. You got 30 volts. Now, the voltage across this one is nothing but the voltage between these two is same. You need to know the current. What is the current actually flowing here? I. I is nothing but 60 by 20 plus 10 plus 30. Again 60 by 60, 1 ampere. When 1 ampere is flowing here, what is the voltage appearing? 1 into 20, 20 volts. Yes or no? Therefore, this is plus minus 60. This is minus plus 20. Then what do you get here? V2. Therefore, V2 will be, okay, 60 minus 20, nothing but 40 volts. Understand all of you? Okay. So W1 will be, what is W1? Okay, half C1. What is C1 actually given? 2 farad, right? So 2 farad into V1. What is what V1? 30. 30 square. So this is 900 joules. Okay. Let me take W2 half. C2, how much? 6 farad into V2, how much? 40 square. 3 joule. So you got, okay, 4800 joule, nothing but 4.8 kilojoule. Okay, so I think all of you understand this. Quickly note down. If you are good at network solving, then it's not a big deal. Only you are applying the DC conditions. Okay. Find CAB. The next question, all of you, please note on that. Meanwhile, I just draw the circuit. All of you, please draw the circuit again. Okay. This is 35 microfarad, 10 microfarad, 40 microfarad, 10 microfarad, 20 microfarad, 15 microfarad, 15 microfarad, 5 microfarad. Okay, so please note on this question. Asking here that CAB, what is the equivalent capacitance value? What is the equivalent capacitance? Okay, so I think all of you can easily recognize the elements which are connected in series, parallel, and so on and so forth. Since this is a zero resistance wire connecting between these 2 points, okay, so this element, this is also zero resistance wire. So probably this point and this point both are operating at same potentials. Yes or no? Even this point also. Yes or no, all of you? Now, can I say these 3 are connected in parallel? If I take this one here, and this one here, and finally this A is becoming here. A is coming to this particular point. Okay? Yes or no, all of you? Or else you can bring this element to this element to this, all these 3 can be connected here. Anything is okay for us, not a problem. Okay? But if I take like this, now look at this, 15 parallel, 35 parallel, what is this? Step. That means what? 15 plus 35, 50, 50 plus 10, 60. 60 microfarad. Because all are in microfarad, I have not written, but in the question you can observe. Now this 15 and 5 and 10 similar way, they are in parallel. 15 and 5 and 10, they are in parallel. 20 plus 10, 30. 30 microfarad. Okay. Now finally what's happening here is, when you simplify this, okay, when you connect this point to here, this point to here, finally this A is coming to this point and B is coming to this point, and something like this. If you join all this, finally, okay, finally it is something like this. This is already there. This is already there. What is this value? Yeah, this we simplified. How much it is? 30. This we simplified. How much? 60. So therefore I can say this is 60. This is how much? 30. But this is already available. 20. This is now A. But already between AB also there is one element. What is that? 40. So now these are coming as A and B. You are now looking into the network through AB terminals. Yes or no? Now tell me opposite direction when we move. These 3 are in series. Yes or no? So 60 series, 20 series, 30. That result is parallel with 40. Now you tell me here, what will you get? What will you get? 60 and 30 series is nothing but 20. 20 and 20 series 10. So 10 parallel 40. Finally you got 50. 50 microfarad is nothing but CAB. This is your answer. Please note down. Okay, you must be good at solving the networks, whether it is resistors, all of you. Meanwhile, I just note down another problem, question number 8. Determine Thevenin's equivalent at the terminals AB of the circuit shown in the following figure. That is the question. Okay. Thevenin's equivalent is expected to determine here. Now, look at this, all of you. Thevenin's equivalent. I think all of you finished that. Now look at this. Thevenin's equivalent we need to determine. That means you require VTH and CTH because all are capacitors. Therefore, we require Thevenin's equivalent capacitance. So now tell me, this is the total voltage, right? How these two are connected in parallel, and that result is in series with 5 farad. 3 and 2 parallel. 3 parallel to nothing but 5 farad. And this 5 and 5 both are in series. Therefore, when they are in series, the voltage will be divided in proportional to or inversely proportional to? Inversely proportional to the capacitor. We know that formula V1 is equal to C2 by. But since 5 and 5 both are same, this is also 5. Yes or no? This is also 5 you got. That means equally divided. Equally divided means VTH is equal to 15 by 2, nothing but 7.5 volt. Okay. For finding CTH, again the same procedure, that look into the network through the terminals where the CTH is to be calculated, suppress all independent sources, that means it is replaced by the short circuit. And now you got something like this, the network. Okay, the network looks like this. AB, 3 farad, 2 farad, 5 farad. When you look into the network here like this, all these 3 elements are connected in parallel. Yes or no? So CAB or CTH, nothing but, when you're looking here, all 3 are parallel. So 5 parallel, 3 parallel, 2. Nothing but 8 plus 2, 10 farad. That is CTH. 7.5 volts and